Guys, this is my first video from the Arithmetic Lecture series and Arithmetic series. So we're gonna we're gonna start today with exercise 1A, which is from your new syllabus mathematics book, and we're gonna do this math problems as I wrote here. I can write the page number, I guess, and the page number is gonna be 14, page number 14, and we're gonna do number 1, 2C, 2D, 3A, 3C, 5, 6A, and 6C. Okay, now students, we're going to learn a lot of things new from here and a lot of things that we did before. So we all need to remember, recall something that we did before, and we're going to do a lot of things here, and we're going to learn some interesting concepts. Okay, now I'm going to start my lecture. Okay, at first, we're going to do number 1A. Number 1, okay, number 1 says, determine whether each of the following is a prime or a composite number. Now, for these four numbers, you can see that they're less than 100, so you need to remember which ones are prime numbers less than 100. So, remember what the prime numbers are. I'm going to still write down here what the prime numbers are. You're just going to remember what they were. Okay, I'm going to say right here. Okay, there were 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 43, 47, 53, 59, 61, 67. Okay, now let's see what numbers we have. We got 67, so this one is a prime number. 71, 73, 79, 81, 83, 97. Okay, wait, I got something wrong right here. I wrote a wrong number, which is not prime, but I wrote it by mistake. So can somebody say what this number is? Yeah, right, it is 81. 81 is not a prime number, it's composite. It is divisible by 9, right? 9 nines are 81. Okay, so this one is something that I got wrong. So we're gonna get the right one now. Okay, so it's 83, 89, 97. So the right one's gonna be 80, 89. Okay, so now the question says, this is a basic level math, and it says which numbers are prime. So from here, my list, you can see that 67 is prime number, 73 is right here, so 73 is a prime number, and 91 is not on my list, so it's not a prime number. So the answer is going to be 87 is a composite number, B is 67 is a prime number, as you can see in my list, 73 is a prime number, C in my list here, and 91 is a composite number because it's not in my list. Okay, so you need to remember these prime numbers from 1 to 100. So if you don't remember, then it might be harder for you to determine if it's a prime or not, because this question might be coming for a mark or two. So it's better if you remembered that. But there is another trick which will easily tell you if a number is prime or not for larger numbers. Now, if you can see really well, in page number 15, there is a question, which is question number, I guess, question number 10. And it is in page number 15. Question number 10, page number 15, is determine the same question, but it has larger numbers. For these larger numbers, you need to do trial and error to find out if they're prime or not. But for me, there is an easier way out. So in next lecture, I'm going to tell you how to find out if a number is prime or not using a short formula. Okay, it's really easy. You can do it easily, I guess, and you just need. I'm going to teach you. Okay. You need to remember a short formula, and you can easily find out whether a number is prime or not. It only works for all numbers except for 2 and 3. You need to remember that 2 and 3 are prime numbers. Except for that, any number you can determine if it's prime or not using those two formulae that I'm going to teach you. Okay, now we're not done with number 1A. Number 1. Now we're going to go to number 2. Okay, number 2 says, find the prime factorization of each of the following numbers, leaving your answer in dexitation. Okay, now here, you learned this before, I guess. We did learn this before, so we're going to do number C and D. And I'm going to teach you how you can do this. It's easy. So, 336. Now find out 336. Now find out the smallest prime number. You know that 2. It can be divided by 2 because you can see there's 6, which is an even number. So we're dividing it by 2. So you get to see it's going to be 2 8s are. Is it going to be 8? Yeah, you're going to divide this by 2 right here. Okay, now if you divide by 2, you're going to find right here it's going to be 168. And then divide this by again 2 because you see that 8 is an even number, so it's divisible by 2. Now 2 4s are 8, 2 8s are 16. Now you can again divide by 2, so it's going to be 2 2s are 4 and 2 4s are 8. Okay. Divide this by 2 again. It's going to be 2 1s are 2, 2 2s are 4. So, and then lastly you can divide again. So it's going to be 3 times 7. So now it asks you to find out the prime factorization right here. So it's going to be these numbers. Okay, so it's going to be these numbers right here. Okay, I'm going to use a different ink so that it's easier for us to understand. Okay, so it's going to be, oh wait, okay, now it's going to be these numbers. So it's going to be, you can see there are 3 2s, so we can write down 2 cubed instead. Okay, we can write down 2 cubed because there are 3 2s, right? We're multiplying them, so it's cubed. Wait, there are 4 2s. I'm sorry, I made a mistake right here. So there are 4, so we're going to write down 4 right here. Times, there is a 3 right here, and there is a 7, so 2 4. 3 times 7. So this is going to be the answer. Easy, right? Okay. Now we're going to do the same thing for 630. It's again easy because we learned this before, I guess. 630. Now divide this by 2. So 2 5s are 10, 1, and then 2 1s are 2, 3, and 2 3s are 6. We can easily say that it's divisible by 3 because if you divide this, you can see that if you add those numbers, you're going to get a number which is divisible by 3. So it's going to be 3 5s are 15, 1. Okay. Divide again by 3, easily understandable. Oh my god, no. Okay, wait. Okay. Okay, so it's going to be this, and then lastly, 7 5s are. So now we can see again, these number products are going to give us 630. So the answer is going to be 2 times 3 squared. There is 2 3s and 7 times 5. Or 5 times 7, whatever way you want to write it. Okay, now you can check these 2 answers from the book. I guess they're right. Okay, guys, so I guess it was kind of like easy math. So you can do the other 2 from the number A and number B by yourself. I showed you only number C and D because you can do the other by yourself because they're so easy. Yeah, they're easy, right? Okay, now let's go to the next math problem. We're done with number 2, C and D. Now we're going to go for number 3. And here we're going to learn a new concept. And this concept is about prime factorization. This is the same as we did prime factorization before, but now we're going to learn how to find out the square root of the cube root using prime factorization. I guess you did do the square root before, but you never did the cube root before. So I'm going to teach you how to find out the cube root today, and I guess it's going to be great. Okay, so let's use this. Okay, we're going to do this again. Okay, now 1764. I'm going to show you 1764 once, and then I'm going to show you 3375, the cube root of it. Okay, so at first you need to do prime factorization, which is so important for 1764. So 1764, let's find it out. It can be divided by 2, so it's going to be 2. Okay, you can just do it. And then 2 again, okay. Then you can see that it's divisible by 3, so 3. I don't know, find it out. Okay. Three again. Okay, we're gonna do this one first. and then 7. Okay, now for 1764, we can write this down, this prime factorization down as 2 squared times 3 squared times 7 squared, as you can see right here. Now, number 3a, right? Okay, now this one. Now, when we're going to do square root, I'm going to teach you the secret right now. When we do square root, the powers of the prime factorization, like the powers of the prime numbers right here. So when I say the word powers, it means this power, and this power, they all gets halved. So for square root, all the powers get halved, because there's a 2 right here, right? Square root. So we can say that all these powers are going to get halved. So it's going to turn 2 times 2 squared is going to get halved, so it's going to get 1. So 2 times 3 times 7, because you understand that all the powers, the square powers, got halved. So there's only 1 left. So it's going to be 2 times 3 times 7. So it's going to be 2 3s are 6, and 6 7s are 42. So the answer is going to be 42. So this is a rule that we learned before in grade 6, and it was about prime factorization and finding out the square roots or the cube roots. Okay, we didn't learn the cube roots. So if you understand this, then we can do the cube roots well. Okay, so you understand this trick that in square roots we're halving it out. We're making it half. The powers are getting halved. Now we're gonna do the cube root of 3375. Okay, we're gonna do 3375. So let's write up prime factorization for 3375. Okay, now here I understand it's divisible by... Oh my god, no. Okay, I just hate this square box made up of this blue thingy. Okay, we're gonna do this 3. Oh my god, I'm just messing this up. Okay, 3375. Okay, we're gonna do this by 5 because we understand it's divisible by 5. So it's gonna be, I don't know what, you're just gonna try this out. 5, 6, or 30, 37, okay. 37, okay, fine. Okay, 5. 5, I guess 15, okay. Three 9s are 27, and 3 3s are 9. Okay, now we can see that these are all prime numbers right here. So now we're going to write down 3375 in the prime factorization form. So it's going to be equal to 5 cubed times 3 cubed. Now what I'm just going to do is we're going to do cube root, right? Now this is, if you understand, if you're really clever, you're going to know how we can do this. It's really easy, I promise. So in the square root, what we did was we made the powers halved. The prime factorization powers halved. But now it's cube root, so we're going to make it 1/3. So here, these powers are going to get 1/3. So if I multiply 1/3 with all the powers, we're going to get 5 times 3. So the answer is going to be 15. Easy, right? Okay, we're going to do a lot more math, and you're going to learn a lot more, so you're going to understand a lot more. Yeah, so a lot of people can have questions. So what would have happened if it was 4 root? Like, there was a 4 root here. And the answer is easy. So suppose there was a 4 root, like that. 4 root. Something right here, like 64. In that case, the powers would have become 4 rooted. So suppose 64. Find the 232, 216, and 2, 8, and 2, 4, right? And then 2, 2. Okay, 64 is not going to have a square root, like a 4 root here, like that. Let's imagine a number like that. Okay, so in that case, the powers would have become 1/4. Okay? Okay, easy peasy. Don't get a lot. Yeah, don't worry a lot about it. Okay, suppose 4 root 16. In this case, 16 is going to be 2, 8, 2, 4, and 2, 2. So the prime factorization for 16 is going to be 2 to the power 4. And now 16 4 roots, like that thing, is going to be called 4 root like that. And it's going to be 1/4 of it. So it's going to be 2 only. So this is easy. So if it was 5 root like that, 5 in top, then that would have been 1/5. So in this way, we're going to be doing this math. Oh, I guess it's going to be really easy. Don't worry much about it. It's going to be super easy. And I'm going to give you a lot of classwork, so you're going to get good marks. Okay, now let's go for the next math problem, which is number 5. Okay, now here it is given that the prime factorization of 21952 is 2 to the power 6 and 7 cubed. Find the cube root of 21952. As I have told you before, that for square root, we're making the powers of these prime numbers halved for square root, and for cube root, we're gonna make them 1/3. So let's just see this right here. I guess it's gonna make it easier. So for a cube root, we're gonna make these powers 1/3. Okay, so 21952, if I write this down in prime factorization, I'm going to write down 2 to the power 6 times 7 cubed. Now, if I want to make it 1, so cube root is going to make these powers 1/3. So cube root makes these powers 1/3, so 1/3 of 6 is 2, so it's going to be 2 squared, and 1/3 of 3 is 1, so it's going to be 7 to the power 1, which is 7. So 2 squared times 7 is going to be 4 times 7, which is equal to 28. Easy, right? Yeah, it's totally easy. It's really easy. Don't make it hard. Don't think it to be hard. Okay, and now we're going to go for the next math problem. And wow, this is the last math problem for today. So it says, this is a new concept again. It says estimate the value of each of the following. So you can see this word right here. It says estimate. Now, a lot of people might not know, or they're not sure about what the word estimate means. So the word estimate, to estimate something, means to find something close to it, but not exactly to it. Now, think about this. You're asked that what's your weight, or what's your mass. Okay, what's your weight? That's how people ask. So you don't really know what your weight is, so you might give an estimate for it. And the estimate is going to be like, I'm like 40 kilograms. That's how you give the estimate, right? You don't know what your weight is exactly. It might be 46, it might be 47, but you don't know what it is, so you're just going to give an estimate. In the same way, estimate means the value is close, but it's not exactly the value. Now, here, this question number 6 is a different question, and it asks you in the estimate of the value of the following. And now you can see there are two estimate questions here. The first one is 66, and the other one is cube root of 218. The first one is the square root. Now, for this math problem, you need to remember the square root of the first 10 numbers, I guess, and the cube roots too. So let's see for square roots of the first 10 numbers. So 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16, 5 square is 25, 6 square is 36, 7 square is 49, and 8 square is 60, and 9 square is 81. Now from here we can see that these are the first square numbers. Now here the question asks you to find the root 66. So we can see the square numbers are 1, 4, 9, 16, 25, 36, 49, 64, and 81. But there is no 66. That means the root of 66 is a decimal number, and we can't find it without using a calculator. So we do not need to find it, but it says estimated. So using these numbers, looking at these numbers, we can easily say that what is the closest square root of 66? We can see 49 square root is 7. 49 is not close to 66. And 64 square root is 8. And 64 is really close to 66. So the answer for root 66 is gonna be 8. And for estimation sign, the sign for estimation is gonna be this. Because 8 squared is 64, which is really close to 66. So it is easy, right? Yeah, it's really easy. Now we're gonna do the next one, which is number 6C. Here, we're gonna do the cube root one. And now for the cube root, you need to remember the first, I guess, I don't know what the school teaches you. I'm just going to tell my one. So you need to remember the cube root of some numbers. So let's say, for example, we can just remember 1 cube is 1, 2 cube is 8, 3 cube is 27, 4 cube is 64, 5 cube is 125. 6 cube is, you can do 216. 7 cube is 343. Now, I don't need to go further to find out what 218 cube root is, because I can see from here the cube numbers are 1, 8, 27, 64, 125, 216, and 343. So I can easily see it, and I can easily say that what number is closest to this 218, and that is 216. So I can easily estimate that the value for cube root 218 is going to be 6. Okay guys, thank you so much for watching this video. I'm gonna do a lot more math and a lot more hard math next class, and for any question you can comment down below for the answers. So thank you guys, and I guess you're gonna get yeah, if you like this lessons, do subscribe my channel and press the like button. Thank you guys. Bye. Yeah, bye.